Ladies and gentlemen, your captain speaking on flight deck. My name is Captain Surinder Singh. Welcome aboard the plane talking. Sit back, relax and enjoy your journey. Instrument, landing system, प्यार से जिसको हम कहते हैं ILS. Okay. Now, what is the purpose of this? This is the simplest way to understand. It is, the main purpose is to provide instrument guidance to land in case of inadequate visual references. Because if you can see runway, then you don't need, that's the best way. When you will learn your flying, you do visual. So that is the main purpose. In cockpit, I have something which I can use it to align. Now, if I want to land, what all guidance you need? Obviously, if I want to land, if this is a runway, I want alignment with the center line, whether I am on the left or I am on the right or I am on the center line. So the guidance, first guidance which you require is that is your lateral guidance. Lateral or azimuthal is the same, horizontally. That's what. Whether you are on the, let's say if this is extended center line which you want to follow, whether you are on the left or you are on the right or you are on the center. That is the first guidance which you need, which will give you the alignment. The second guidance which you need is vertical, or you can call it glide slope. Means if you want to land, any case, this is the glide path, whether you are above or you are coming via road. So that guidance you need it. So that is vertical or glide slope guidance. That is, so you have lateral and you have vertical guidance also. The third guidance you need is how far you are from landing, touchdown. Okay. So the third guidance which you need is range information, how far you are from touchdown. If this is my touchdown point, I am on correct glide slope on center line, I need to know that what is my distance from touchdown. So these are three information to get your position in 3 dimension in space, lateral, vertical and distance information you need. And this is the instrument which was invented in 1930s. They started using in 1938, 39 or so. So almost reaching to close to a century, and nothing much has changed other than one component. It is same. So this information, lateral information, is provided by equipment called Localizer. This information is provided by, we have a Localizer equipment, we have glide slope equipment, and we have how far you are from touchdown. This is given by marker beacon. Beacon is anything which is giving the direction or position. Beacon, you have a light beacon also. So there are 3 component or element of ILS: Localizer, glide slope and marker beacon. So this is like a animation kind of thing to understand before we study theoretical aspect. So this is the 3-degree glide slope, yellow, which you want to land. So you have an antenna, it is called Localizer. You have an antenna which is transmitting, directional antenna, it is transmitting. And then it is a glide slope antenna, and in between you have those 3 marker beacon. So that is your extended 3-degree glide slope. You want to follow that in case you don't have adequate visual references. So in the cockpit, these are the 3 elements of your indicator. One moves left right, whether to go to left or go to right, something like this. That is for Localizer. And one goes up and down to tell you fly up or fly down. This will tell you fly left or fly right. So 2 things are taken care of. So all you need to do is what? To maintain a plus sign, basically both centered, and you will be on your desired glide path. The third thing is how far you are from touchdown. So that time technology was not that advanced. So what they used to have, transmitters, directional transmitter, which used to transmit vertically up. So only once you are on the top of the transmitter, you will hear that signal. You have in the cockpit lights, these 3 lights, and the audio also comes, so that you know how far you are from your aiming point, touchdown point. So all, let's say if you are going below the glide slope, it will tell you fly up. If you are going left, right, so it is a continuous update. All you need to fly is follow this indicator. And when you are exactly over this, you will hear the audio and light comes on in sequence. They are blue, orange and amber and white. So when aircraft comes exactly over this, you will have this light and audio, and this distance is given on your charts. Navigate, you will see those. So this is the audio which you hear when you are over the marker. So you hear the audio, dash, 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 and plus this blue light comes on that, and this distance is given in the chart. You know how much is this distance, so how far you are from your touchdown point. So dot dash, that is the audio which you are hearing, and this amber, which is more of orange kind of color, that light comes on. So that is the dots which you hear. So you come down to some height, which is again, that is called category of minima. If you see runway, you land. If you don't see runway, you go around. Missed approach procedure, that's what you do. So this is the first ever ILS which was used when they started flying. Nothing is changed. Okay, the working principle, it is same for so many years. So that's how this localizer antenna looks like. On the end of the runway, we will see layout also, how what distance it is, that also we will discuss. So we have a localizer antenna, you have marker beacon which is transmitting vertically up like this, and then you have those glide slope also, that is your aiming point, touchdown. So next to that, on the runway, on the side, this antenna is. So there are 3 components: glide slope, localizer and marker beacon. In the cockpit you have like basic Cessna or even normal aircraft glass cockpit which you fly, DA-40, they are glass cockpit. So you have your primary flight instruments and you have radios. So in the radios you tune the frequency is tuned here like a normal radio, that's what you are doing. These get activated when you are in approach. All you need to do is just follow this indication, and you can see here it is written, this is blue, amber and white. So these lights are also there. Clear orientation with the equipment, what this equipment is in the cockpit, on ground, how it is. Now let's talk about localizer. So localizer, the purpose is to provide lateral guidance, whether you are left, right, that's what it is, the main aim. It works on principle of bearing by lobe comparison. Bearing is direction, lobe, yesterday we saw lobe is a beam. We will see in that detail how it works, but basically it is bearing by lobe comparison. Okay, or another term which is used is called difference in depth modulation. Again, we will discuss in the working what is the meaning of this. But in simple, it has to be some lobe, some comparison and some difference, something in simple understanding. Now frequency wise, it transmits from 108 to 112 megahertz. Just for your knowledge, we have something called FM radio which we listen to. So FM normally plays from what to what? Yesterday we discussed your FM works from roughly 87 and it goes up to something 107 point something. Now from 108 to roughly 118 we use for equipment VOR, and part of that is for ILS also. Can you see this? The moment the FM radio wave finishes, it's starting there and goes up to 112, and it is combined sharing. We will study equipment called VOR and ILS. They share that band, and above that 118 to 137, actually 136 point something. So 137 we use for your aeronautical communication. So these frequencies are from 108 to 112 megahertz, and it is shared with something called VOR. So when it is shared means some frequencies are for ILS, some frequencies are for VOR. So how this sharing is done? That is an easy way to remember. That is for localizer, L for localizer, V is for VOR. O is odd, E is even. Now what is the meaning of this? We have seen from 108 to 112, it is shared like this. So all odd first place after decimal, therefore localizer means, for example, all those frequencies 108.7, 110.3, 111.1, 109.5. So after decimal first place is what? All odd, that is for localizer. Okay, all even first place after decimal are for, so for VOR they are all even, first place after decimal. For example, 110.6, 111.4, 109.2. They are all first place after decimal, so they are for VOR. So the equipment is also designed in same manner. If you tune odd, it is for localizer, and if there is a transmitter localizer on the ground, it will start receiving the signal. If you tune even frequency, it will tune on to the VOR. Clear on this? Which band it works? It is from 108 to 112, we saw, and it is megahertz. It has to be in what? HF, VHF and UHF. Between 30 and 300, it is VHF band. We have seen how this localizer antenna looks like. It's an array. Array means something you put in sequence, that is called array. So localizer antenna is, this is the runway and this is your landing direction. So other side, which let's say if this is your touchdown end, other side you have localizer antenna. Here, which you saw those antenna arrays this side. What distance we will see layout later. But you saw that antenna? Now that antenna is a directional antenna which transmits only in approach direction. It transmits two lobes of different frequency. Remember what we saw 108 to 112, it is a carrier frequency, it is not the information. Now what the information is transmitted on that is, there are two different lobes, directional lobes. In the approach direction, on the left side of the approach, it transmits a directional lobe of frequency 90 hertz, and the same antennas, they transmit another lobe of 150 hertz, which is right side of your approach direction. So on the right side of extended center line, this frequency is 150 hertz, and both these lobes are perfectly intersecting at extended center line, and they have been given name. Okay, it is not the color or something. The 150 hertz lobe, they referred it as blue lobe, and left of the approach of 90 hertz, they named it as yellow lobe. So there are two different information on the carrier frequency. One is 90 hertz, one is 150 hertz. Now it has become very simple. Difference in depth modulation. So if you are left of the center line, which signal you will receive more? 90 hertz. If you are on the right, so simple, bearing by loop comparison. It makes perfect sense. Easy way to remember, because you do have question in your exam. The moment I think of yellow lobe, I make it in my mind. So yellow is 90 hertz. There is no confusion. So if I am on the left of the approach, I will receive more of 90 hertz. It will give you fly, right indication. If you are here, which signal you will receive more? It will tell you fly, left indication. And if you are exactly on the center line, both this modulated signal of 90 hertz and 150, they will be received in equal strength. The difference in depth modulation will be 0. So when you are here, your pointer will show continue straight. All you need to do is this. You are deflected more, the deflection will be more. So as you start coming, it will keep reducing. When you come here, it will become center. If you go to the other side, pointer goes to the other side. Then you start coming, it will start reducing. So all you need to do is follow this. Now obviously it is a beam, it is a cone, it is a directional transmitter, so it has got coverage area. It is important because it is also asked in your exam. So that's how it is a coverage area. So horizontally, as aircraft is far, this coverage area is less. As you keep coming closer, it will keep opening up. Your glide slope is 3 degree, so vertical coverage is up to 7 degree. So well above and below the glide slope, this signal is received. So if you are on the left, you are receiving more of 90 hertz signal, and if you are on the right, you are receiving more of. So here it will tell you fly right, here it will tell you fly left, and when you are on the extended glide slope, all you need to do is continue straight. You have both horizontal and you have vertical. You have seen up to 7 degree. So horizontally, as aircraft is far, this coverage area is lesser, and as you keep coming closer to the runway, it keeps increasing. So up to 25 nautical mile, this signal can be received up to plus minus 10 degree either side of extended center line. As you keep come closer, it expands, means you can receive up to 17 nautical mile, you can receive the signal up to plus minus 35 degree. As aircraft comes further closer, this signal can be received up to 10 nautical mile plus minus 90 degree. Vertical coverage area you have already seen up to 7 degree. So vertically this can be received up to 25 nautical mile. So your normal glide slope is what? 3 degree. So if this is your glide slope, well above or below, the signal can be received. Let's see glide slope. So glide slope, it gives you vertical guidance. So it provides vertical or glide slope guidance. It works on principle of bearing by lobe comparison, same, or difference in depth modulation. It is the same principle which is used. So obviously you will have two lobes depending upon the position of aircraft. Obviously you don't want any interference, that localizer signal affecting your glide slope signal. You don't want any interference. So that's why the carrier frequency is different. So frequency for this is, so it is 329.3 to 335 megahertz. So it is between 300 and 3000 megahertz. So which band it is? It has UHF band. Again examination question which is asked. So you will find the frequency is also given there. ILS frequency 110.3. Similarly, where the frequencies are given on the top left also you will find, you can see that localizer frequency 1103 is given. Correct? You got it? 1103 frequency. Where is the glide slope frequency? It is not given. Then how do you tune it? So it is not given in the chart primarily because it is paired with ILS localizer. Now what is the pairing? Earlier we saw sharing. Sharing was some frequencies are for VOR and some frequencies are for ILS. Now pairing is, means if you select one frequency, other is automatically selected. Whether wherever it is, this 1103, the corresponding glide slope frequency will be fixed. This pairing means once frequency is selected, the corresponding frequency is automatically tuned. So both equipments are basically programmed, you can say. You select one, other is other. Why? Obviously to reduce the cockpit workload. Rather than selecting two different frequency, one is selected. The ground transmitter is also programmed like this to reduce cockpit workload, obviously quick frequency selection. Now again question is, what is the band? So it works in the band of UHF. Wait, let me show you how this frequency pairing is done. This picture is from ICAO publications. You have annexures. So I have taken this picture from this. So you will find there is a localizer frequency. For every localizer frequency, can you see this all are odd? After decimal, there is a fixed glide slope frequency, something like this. So all those frequencies, whichever it is, there is a fixed glide slope frequency, that is frequency pairing. Okay. So for every localizer frequency, 110.3, you cannot choose any weight frequency. For 1103, which will be anywhere in the world, your glide slope frequency will be 335 megahertz. Let's see working. Tu has le pehle. Let's see how it works. It is the same. There is no interference because one carrier frequency is in VHF band, one frequency is in UHF band. Antenna position you already seen where the touchdown point is. Next to the touchdown point you have glide slope transmitter. So bearing by lobe comparison, you have 3-degree glide slope, that is a normal glide slope. So next to your touchdown point, you have that antenna which is transmitting in approach direction. So it transmits two lobes in approach direction, one above the other. So the bottom one, easy way to remember, is blue, and the top one is yellow lobe. What information is there? It is a radio signal. This is of very good, genius, 90 hertz and named as yellow lobe, and this is exactly same, 150 hertz blue lobe, but they are not interfering each other because the carrier frequency is different. Now it is very simple logic. Is if you are above glide slope, you will receive more of 90 hertz, so you will get indication fly down, and if you are below, you will receive more of 150, so the indication will be fly up, and if you are on the extended glide slope, correct, it will be perfectly horizontal. This picture is to show you the position of the glide slope transmitter. There is a shelter in which the equipment is placed, there is an antenna, and you can see those transmitter signal aerials. They are transmitting in approach direction. So, if you are coming via road, fly up, you will be receiving more of 150 Hertz modulation. When you are above, you are receiving more of 90 Hertz. So, fly down, and if you are on the correct glide slope, it will show you horizontal. So, this is your localizer antenna, this is your glide slope antenna. So, let us see coverage area of glide slope. If is extended center line, either side of the center line, this signal can be received up to 10 nautical mile within plus minus 8 degree. So, practically when you fly, first you come on the center line on localizer, you are coming on the center line. Now, as you come to the glide slope, then you descend. Similarly, you have for vertical also above and below glide slope. So, for vertical also, whatever your glide slope is, let us say 3 degree glide slope theta. Now, this signal is transmitted both above and below this. So, now the coverage area is something like this, above and below glide slope. Above it is 1.75 theta and below is 0.45 theta. Theta is your actual glide angle. So, well above and below the signal can be received. For 3 degree glide slope, 0.45 into 3 to 1.75 into 3. So, for 3 degree glide slope, the signal can be received from 1.35 degree to 5.25 degree above. And the third component is marker beacon. Now, over a period of time, this is the only component which is replaced with the DME, distance measuring equipment. So, when this was invented in way back in 1930s, technology was very primitive, or the advancement was not that which came later on. So, that time they wanted to know the decision, they came up with a simple solution that transmit vertically up. When the aircraft is above that, it will receive the signal. You saw that antenna, how that antenna looks like. This is a marker beaker antenna which looks like it transmits vertically up. So, only when the aircraft is over that, it receives the signal. So, what are these marker beacons? Now, these marker beacons are referred as outer marker, OM. It transmits. Obviously, they are not too powerful because you want that aircraft receives signals only when it is on the approach. So, only when you are in your approach path up to certain. So, normally they transmit roughly about 3000 feet above the ground. Obviously, when aircraft comes over outer marker, you already seen you have blue light and you have a low pitch audio of 2 dashes which you hear. Similarly, as you come closer, you have inner marker, amber color. Amber is more of orange, and that is referred as middle marker. And when you over this, you hear dot dash and in high pitch. So, over this, you will have amber light in the cockpit. That's what comes on. And when you are over inner marker, which is white light, and you hear dots at high pitch. So, easy way to remember is BAW, blue, amber and white. What is the distance, recommended distance? We will see in the layout, how the total layout. But that is how it is. When you exactly overfly this, you hear the audio and you see the light in the cockpit. The audio which you hear here at outer marker, it is of 400 Hertz audio. When you are here, it is 1300 hertz audio, and when you are here it is 3000 hertz audio. Standard layout, how it should be. If this is the runway and this is your extended center line, other side of the runway you have a localizer antenna. In your approach direction, 300 meter upwind is those array of antenna which you see localizer, the sequence of those antennas. So this is distance is 300 meter upwind, means into the wind in your approach direction, which roughly works out to 1000 feet. Glide slope antennas you have seen next to your touchdown point. So on ILS approach, your touchdown point is 1000 feet from the beginning of runway. Okay, beginning of the runway is called threshold. So ILS threshold is 1000 feet ahead, which is roughly again 300 meter. Here on one side, normally on the left, you have glide slope aerial or antenna. This is for the safety, because this is the approach on instruments. So even if there is some inaccuracies, you are safer, you are going ahead. Now the marker beacon, okay, whatever the marker beacon distance is, practically when you fly, it is given on the charts. It is always there on the charts. So for the outer marker, distance from ILS threshold recommended is 3.5 to 6 nautical miles. It may vary, but whatever the distance is, it is given on the chart. Coming to the middle marker, this is normally fixed. This is 3500 feet from ILS threshold. When you are over this dot dash which you hear, when you are over this, this corresponds to ILS Cat 1 minima. We will see category of ILS tomorrow. Inner marker also, which was just as you are entering the runway. It is just about, how much is this distance? 1000. So this was just 1050 feet. So from the beginning of runway, how much it is? Just 50 feet. That time it corresponds to, we have something called Cat 2 minima. Later on this was removed. We have more accurate thing of DME, distance. They give you the exact distance right up to touchdown 0. We will study that also. When we will study DME, that time we will study ILS DME. So this is replaced with ILS DME. But where the conventional setup is there, you have those 3 marker, and this is the position. Copy this. We will go for break. See you after the break. This is your captain speaking.